In this final video in the basic compression tutorial series, we will apply an SSDR stage for additional compression before exporting our capture for playback. SSDR, short for smooth skinning decomposition with rigid bones, is a kind of mesh-based compression we can apply in HoloEdit. SSDR requires that the track's mesh data is stabilized. In part 2 of this tutorial, we applied stabilization to our data with a stabilized mesh stage. But if you are working with data with existing stabilization, this stage can be completed immediately following the load asset stage. To add the SSDR stage to our track, press the Add Stage button and select SSDR from the drop-down menu. Once an interval has been created, the SSDR stage automatically generates segments based on the existing stabilization data present in the track. On a given stage, intervals specify what frame range processing will be applied to. Like most stages, the SSDR stage is configurable in the inspector. We're not going to be changing any of the parameters for this example. Next, let's execute our SSDR stage. Right-click on the interval and select Execute from the drop-down menu. It will take some time for the stage to process. We'll wait for it to finish returning results before we continue and export the clip. Now that our SSDR stage has finished, we're ready to export our clip. First, a little background on holosuite's volumetric file format, OMS. Open Mesh Sequence, or OMS, is a file format designed for storing and playing volumetric video. OMS files are small, portable, and optimized for fast loading and playback. With playback plugins targeting Unity, Unreal, and web playback, OMS files allow for easy transfer and delivery of your volumetric video projects. OMS files contain mesh data, provide optional compression, and support skeletal data for animation and retargeting. For this tutorial, we will be exporting an OMS with an accompanying MP4 video file for the texture data. To open the export window, select File from the menu bar and choose Export Composition. At export, HoloEdit exports the results of the entire composition using the data from the bottommost interval for each frame. Because of this, if any frames in our export range did not have SSDR applied or have not completed processing for SSDR, the result of the stabilized stage above will be exported for those frames. We used each of our stages for the entire frame range to maximize compression, but in more complex projects, many stages may only be used for some subset of the composition. Next, we'll figure out the export settings. First, we will select a location for our exported clip. Click on the white box below Output Path that says Click to Select Directory to access the File Explorer. From there, choose a folder for where you want to export your OMS. For this example, we'll use a new folder somewhere outside of our workspace directory. Unless you intend to immediately use the results inside of your composition in HoloEdit, you should always make sure to export to a location outside of your current workspace so the results are not indexed and metafiles are not created. Below the Output Path field, we can see the frame range indicators. These can be configured to choose the start and end frames as long as the data we are exporting exists inside of that range. The export composition will only export frames with intervals present in our composition. For now, we want to export the whole clip from frames 0 to 239, so we can leave these settings as they are. Now that we've configured these settings, we're ready to set up our export steps. Press the plus button to the right of Export Sequences to open the new Output Sequence window. This window lets you add a new type of data to be exported. When exporting, you'll typically configure multiple data types to all export simultaneously. Enter the name for your exported files in the Output Sequence file name field on the top left of the new Output Sequence window. We'll call ours Basic Compression. Choose the output type you intend to export. We're looking to compress our clip for playback using the OMS format, so we'll select OMS. After choosing an output sequence type, we can configure our export settings as needed for that file type. For OMS, the available options are bit packing, retargeting, and minimum SSDR encoding frames. Bitpacking is one of the elements that add additional compression. It is currently a mandatory option. Retargeting sets up the OMS to include animation data generated using the Generate Skeleton and Generate Skin Weight for head retargeting stages in HoloEdit. Having it enabled without skeletal data present won't cause any detrimental effects, but we'll go ahead and disable it for this clip. Minimum SSDR encoding frames, which allows you to override the minimum size for SSDR segments to be compressed in the results. This is an advanced setting, which should typically be left at the default setting for a good balance of compression and correctness. With your desired settings in place, press Save, and the prepared export will be added to the Export Final Composition window. If you'd like to adjust the settings of an export after adding it to the Export Final Composition window, you can click on the gear icon to reconfigure the settings or the X icon to remove it. In addition to the OMS mesh stream, we'll need to export a texture stream for the OMS player. OMS Playback supports multiple formats, but in most cases, compressed MP4 format textures are the best choice. In this tutorial, we will export the MP4 format. Click on the plus icon to add another export step. We'll set the name of our MP4 export to basic compression as well. For this export, we'll select the MP4 as the output sequence type. Changing the export type will change the parameters available to be adjusted. MP4 export provides settings for bitrate, the codec, resolution, encode frame numbers, and custom quality arguments. By default, texture export will use the resolution of the PNG files you originally imported along with your clip. For now, we're not going to change any of these settings except for resolution. The default settings should work for most simple captures. But MP4 decode at higher resolutions can be hardware intensive, and we want to make sure our clip plays without a hitch on any platform. We'll set the resolution to 1440. Save the MP4 output sequence settings, and now we have our OMS and MP4 files ready for export. Down at the bottom of the window, press Export. A dialog window will open up displaying the progress of the export. When the export completes, your output file location will open, showing you your exported MP4 and OMS. The results of this tutorial are ready for playback in any supported OMS player. Arcturus provides OMS player plugins for Unity, Unreal, web, and streaming. Please check out our additional tutorials for setting up the OMS player and applying head retargeting, linked in the description below. Thanks for watching our tutorial series on basic compression using HoloEdit 2020.4.